All right, I want to explore the function we were looking at in the previous video here. Let me get my window centered here. And so we're just going to look at the graphic representation in 3 dimensions of our function. So our function was 2x cubed minus 6x times y plus y squared plus 7, and we found critical points at 0, 0 and 3, 9. So I'm going to, for right now, look at x going from -4 to +4 and y from -10 to +10. And so here we have our oddly looking sheet. We can look at it on the side. We can look at it at a XZ graph, and we can see what this sheet looks like looking from -4 to 4 in X. I can come over here and I can look at a YZ graph and see how this thing looks looking at it from the side of Y and Z. It zoomed in on me here. Let me try to zoom out a little bit as we try to fit things in. But we have our function. We can see that the curvature of the surface has some features on it. So let's first try to look at that saddle point that was at 0, 0. So I'm going to get really close to it. I'm going to go from -0.1 to +0.1 on both the x side and the y side. And here, I think we can quite clearly see that saddle point, right? It's coming across diagonally across the xy, where the multiplying of xy happens, right? That middle term is -6xy. It's getting this multiplier here, and this kind of, and then in the x cubed and the y squared kind of have parabolic and cubic functionality happening also in here. So kind of have this arcing down here and this arcing up here, and we do get a saddle point right in the middle. So our our calculus approach to finding the partials and seeing the saddle point match what we see if we really zoom in on this graph. And so our other point was at 3, so I'm going to do the same thing. I'm going to get really close to it, 2.9 and 3.1 in the x direction, and 8.9, whoops, and 9.1 in the y direction. And here we can see that minimum, that local minimum that's coming across on the surface. And it is a trough, but that trough does have a little bit of curvature as we look across it in the y direction, and it definitely has a curvature in the x direction. So the behavior of our graph, there is a minimum right there in the middle. Kind of, let's see if I increase the y value a little bit here, if we can see it curving up a bit more. Right, we can kind of see how it is riding into a lower value here in the middle of the y's, around 9. Let's give it a little more here. And now we can see that curve coming in here. If I look at my x values, right, that x trough, and then our y value troughs, we can see it kind of hitting towards a low point at 9 there. So, when we look at this surface on a large scale of -4 to 4 and -10 to 10, that local behavior is a little hard to see. But if we zoom in near those critical points, we can find that function, find that behavior, and our using the combination of the Hessian and the partials, we're able to find where those fixed points are.